Hi Monty and Amy. Let's review then this idea of linked data tables. How do we assemble them from the RDF format? So the fairer linked representation of data. We'll compare it with the traditional tabular formats as we go. Okay, so what I'll do is that I'll go through the use of the tool with the first example, and then we'll look at two more examples and we'll come up with a fourth. So starting with the first example. So if you click here, you see that the tool is now going to be concatenated with the link of a data source. Here we go. And this data source comes from CDC and includes the 10 first weeks of 2021, and we're looking at mortality data. So notice that when the data was loaded, this description of the data set was pulled from that single URL. So all of this is coming from that single URL. We could be loading this as CSV data, so it's the same thing in CSV, where we get the exact same values. Let's look at them, 87010, 87010. So these tables are equivalent at a literal value level. But you'll see that the RDF table, or the table assembled from the RDF data, will include the context and will allow for levels of portability and reusability that could not be met by the conventional flat table. So let's have a look at the format. So as you move things over components, things will be shown. So let's make sure we see the difference first between the flat CSV table, there it is. So this is a snapshot, the context will be lost, and now compare this with RDF data format. So what you see is that the RDF data format is not as intuitive unless you become used to the RDF format. First, you could find out that you have the prefixes here, you have them on your left hand side for convenience as well, and then you have the rows. See here, so the same resource, the row, and then the values for this row, and then the next one, and on and on. So these formats, they basically weave links between all components of the data structure, and that's what guarantees its portability. As you can see from the namespaces themselves go all the way back to something you can dereference. For instance, here, you'll see you have the same link you have here, see, RDF about, the exact same up to here. And it's telling you that this row is a member of this resource. So this is a row of the resource table. And indeed, if we go here, now let's recall, this is weekly provisional counts of deaths by state and select causes. So if I put it here, it will be dereferenced by CDC accordingly. There we are, same place. Okay, back to the example. So now we can go through the table and dereference everything. For instance, we can go all the way to what is the date for updating this row. See here at the end. So it was updated a few days ago, 1st of December at 4:56 p.m. So all this data is kept and available to you at any point. Same thing for the individual observations. For instance, if I pick this one here, 61,799, this is death by all cause, and you see here the description of the tool. Remember, all of this is being pulled. Sorry if I'm repeating myself, but it becomes very important as we start thinking about integrating data from multiple sources. So you see here that we are getting the information for a specific element, and we have the ability to call both the row or the source, so the parent element. It's all there, and you see the values changing as we go on. So 61,799, it's the same value here. Now I could say, well, but we like the convenience of the tabular format. So let's copy the table. Let's go, for example, to Excel. I'm just doing copy paste, so paste. And you see the exact same information now in Excel. A lot of modern tools, they support the web format. So when you copy paste, most of the links will come through. You won't have the links for the individual elements, but for instance, if you just want to see malignant neoplasms, for example, through these 10 weeks, so you go back to the web page, and now you can see the whole table if you need to. But all of this came through directly from something that had been pasted in Excel, just the same way that before you had the CSV file without those links. So nothing is lost. To finish, let's have a look now at the other examples. So in the first example, we're looking at data from COVID, or from mortality, of which COVID was one of them. This is a published paper, August this year. And you'll see that there is a tool that makes use of the same data sources we are exploring here. So if I go to the tool itself, you'll see that something graphic is being assembled from the same data source. So here, if you compare, you'll see it here at the bottom left. If you compare the link, the reference ID that ends with JTE6, you'll find out this is the same one you had before here. JTE6, there it is. So this reference by itself is enough to retrieve the data. Here we are doing it with more granularity, so 2 constraints, only 10 and only 2021. And the next example will explore this further. In any case, the point is that the tabular format is just a potential visualization of the same data. Another one could be, for example, a graphic representation. Back here. So now we'll move to the second example. In the second example, we are looking for data for a whole year, and we're going to choose to do it for 2017, of any care facility in Manhattan. So the second example is illustrating the engagement of a care system, and we'll be looking at discharge reports, looking for a rare event, which is women under the age of 30 being treated for breast cancer. So this should be a small number of people. So let's click on it, and we find out indeed there are, I believe, 8 people in 2017 in Manhattan that fulfill this requirement. And you see the same features as before. You can look at the columns, you can look at the values for a number of things, all the way to costs. And information about all those costs are calculated, show up here. This data set is also a good opportunity to show that the fairness of a resource is a moving scale. So for example, of all the things you have here, there is one that will not dereference, this one, see, data set missing, and which the point it makes is that being fair is not about having all the checks in a checklist, it's about moving along a gradient where more and more of the context is captured and linked to the data as it is presented to an analytical tool or to a domain expert. So the third example is very different from the other two. We are looking for up-to-the-minute data on police calls in the city of Dallas in Texas. So this is an example of another data source that is in the public domain, which we can traverse and contextualize in the same way. So let's look at it. What's going on in Texas today? I think it's about 11 a.m. in Dallas right now. And you see it's mostly traffic accidents. This of course changes throughout the day. At the end of the day, other types of accidents become more prevalent. But there it is. So this is real time. You see the data here. You can get more information about what each of these fields means. For example, let's go back to the top. So date, see here, calendar date, priority is between 1 to 4, 1 being the most urgent. So there's a lot of information, context information that is delivered here. And of course, each of the individual observations, each of the individual incidents, they have a representation that can be fully tracked to the context they come from. To finish, I'm going to come up with a fourth example. Let's go to CDC. And we're going to look for something like cancer, smoking, maybe something that has geographic granularity. And we have here census tract level data. And so now we're going to use this element here. One good way to get it in the Socrates environment is just to copy it from the API endpoint. And if you dereference in JSON, you get the JSON structure. If you dereference as a CSV, you get the table. And if you dereference from RDF, you get the context. So CSV. And now we'll do the context with RDF. You see here that it's taking a while to retrieve the data. It's probably a lot of data. I'm going to restrict this example to 1,000. So 1,000 rows. So tabulate, it's now assembling data from 1,000 rows, full context, and there we are. Again, all the context is preserved. In this case, including the row information. So we can go further down and see for a given row, what type of information do we have. There it is, all the way to the update date. And some information that suggests geographic localization. Yeah, that's it, place track ID. All right, we'll end here. You can, in principle, any URL from a Socrata-like RDF rendering resource, which includes a lot of federal institutions, state health institutions, and also open city data, as you saw from Dallas, should be available to you. All right, bye now.